All right. Make a sketch of the region and its bounding curves. Find the area of the region inside the curve, r equals square root cosine theta. So it's going to be one of these graphs. Again, I'm not going to, I don't even think I put a graphing problem on the final, but just put in 0 for theta. Cosine of 0 is 1. Square root of 1 is 1. So you look here. When theta is 0, you're pointing to the right here. You should have a point at 1. This one does. A is a possibility. B, nope, not a possibility. C, nope. And D, nope. So just do something like that. Use process of elimination and get it. All right? Now, the area. So r equals cosine theta. Square root cosine theta. And these problems are rigged to work out nicely. All right, let's think about this. Our bounds are determined by theta. What theta has to do to generate this, what it has to begin at, and what it has to rotate through. Okay. What's that? 1 second. I gotta turn my ears louder. Okay, now try it. Okay. You might be tempted to think it's 0 to 1 because look where my mouse is pointing, that's 0 and that's 1. And in the first semester calculus, finding the area of a curve in rectangular coordinates, we would integrate from 0 to 1, right? We're integrating over the rotation, not over the movement on the x-axis, over the rotation. So, does this move?
It'll go back though. You can move it temporarily, but it'll go back.
Yeah. So, look where my mouse is. When theta is 0, it's pointing that way, right? It's pointing out this way. Does that make sense? We have to find out how much theta has to rotate to generate this shape. So when theta is 0, it's pointing out this way. That's why we have theta is 0 and r is 1 right there. So 1, 0 with r is the coordinates. There where my mouse is pointing. Well, let's think here. If theta rotates to pi over 2, 90 degrees, cosine of 90 is 0, right? So when this thing rotates around to there, that's like 0 to pi over 2, isn't it? Then from pi over 2 to negative pi generates the bottom. You see that? So theta has to go from 0. I said negative pi? I should not have said negative pi. Pi. Pi over 2 to pi generates the bottom. Let's... This one's actually even different than that. We're suffering right now because we didn't do a thorough study of graphing these things. We need a few more class sessions to do it thoroughly. All right, when theta is 0, cosine of 0 is 1, square root of 1 is 1. So right out there is 1, 0. Now remember, that's radius 1, that's 0 radians. This is not x and y. So there's a point. When theta is pi over 2, cosine of pi over 2 is 0. So that rotates it around to here. That gives us that part of it. Now, we can't continue. If we put in pi for theta, what's cosine of pi? -1. Now we got the square root of -1, which is I. And we're limiting ourselves to the real numbers. We can't use imaginary or complex. Does that make sense? How do we generate the bottom half? We actually have to start at -pi/2. Okay? -pi/2. Remember, 0, pi/2, this, that's that. If you go back this way, this is -pi/2. Cosine of -pi/2 is 0. So that gives us this point again. All these negative angles in quadrant 4, cosine is positive. Cosine is like the x coordinates. They're all positive here. So that'll generate positive numbers, and it will generate that part of it. All right? So our bounds are going to be -pi/2 to pi/2. Now our area, 1/2 times f of theta squared, this is f of theta right here, r is f of theta, square root cosine theta squared d theta. That is our interval. Now, do you agree that the top half and the bottom half are identical? Do you agree it's symmetric around the x-axis? The top half and bottom half are identical? So, what we can do is, we can multiply it by 2 and go from 0 to pi/2. This will only calculate the area of the top half. Since the bottom is identical, we multiply it by 2, and then that gives us the area of everything. All right. Now, let's pull the half out, which 1/2 times 2 is 1. So we just have a 1 out there. Let's square the root. The square cancels the root and gives us cosine theta in here. Antiderivative of cosine theta is sine theta. Bounds 0 to 1. 0 to pi/2, I'm sorry. So plug in pi/2 minus 0. What's sine of pi/2? Cosine of pi/2 is 0. Sine is 1. You can get those from your unit circle. All right, this one should be 1. Sorry. That is correct. Do you agree the bounds are the hard part?
Yeah.
Yeah. That's, I think all your examples for number 3 are gonna be like that. So they might throw in a coefficient there. That is not gonna change it. What would change it is if they put a coefficient in front of the theta. That would change it. But as long as theta stays like that, oh, that one's sine theta. So if you get one with sine theta, your bounds are going to be 0 to pi. Because that covers quadrants 1 and 2 where sine is always positive. You see, we did negative pi over 2 to pi over 2, quadrants 4 and 1 where cosine is always positive. For this one, it's going to be where sine is always positive, 0 to pi. Now you can go 0 to pi over 2 and then multiply it by 2. You can do that too. Okay. All right, let's go on here.